I will tie it to ground. So let this be a rope. This I'll call a rope. Then I'll switch on the rocket. Initially it's having a mass. At t equals 0, let mass be m naught here. Now I'll ignite the rocket. This rope, what happened, will not permit the rocket to. I'm showing some like a mass of the rocket like this being fuel being burnt. So here the gases will be ejected, and this is a rope. No, it is being ejected with a speed VR, and it is being burned fuel at a rate m, that one. What can be the tension force here? The string will be taut. The string will be taut. Initially I adjusted the system, that one. So the moment I switch on, the rocket wants to move up, no, because of thrust force. Then the weight mg will act. Then the tension T will be acting in this direction. Then what is the expression for tension in the rocket, in this case, Ft minus mg minus T equals 0. So what is a thrust force? Thrust force equal to Vr dm by dt. Now dm by dt. This will be mg equal to T. Now what is Vr? The speed with which gases are ejected, and this is mu. What is m? M naught minus mu T. So this is the expression for tension. Now look at they'll ask you to plot tension in the string as a function of time. So tension in the string will increase or decrease with the time. Mu Vr plus m naught G minus mu Gt. So with the time, this quantity initially T equals 0, okay, well, let's not bother. So the moment I switch on, then what happens, the tension will acting. So at any time T, what is the tension, I'll ask you. Substitute that value of T here, you'll get the tension in the string. So this rope will not permit. So when they are at a testing stage, no, like this, what happens, their questions will be asked for it. Find the tension in the rocket, tension in the rope at any time T. Just substitute all the values. And now instead this, sometimes the rocket, I will place on horizontal surface. I'll place on horizontal surface.
Sir,
Then,
sir, small doubt in the previous equation, sir. Sir, once can you scroll up? Sir, in the second equation, sir, how did it become plus mg, sir?
Thrust force, already I took the sign. It is acting opposite to that one.
Okay, sir. Okay, thank you.
Gradually you can understand. This is a T equals 0. This is a rough surface. I'll put it. I'm trying to generate here now more generalized idea. Rocket propulsion, okay, that's there in NCERT book, that much only. But here we want more generalized. We are going to discuss problems related to all mechanics ideas still now. So what is like thrust force, like with tension, thrust force with friction, thrust force with spring force, like that several thrust force along with all other forces related problems. That is what our goal. Now I'll switch on the rocket. Then the fuel will be burnt. It is being continuously burnt, and the gases will be ejected here. Now, what is a system? See, like how to, now you can ask me one best question like, sir, how you determine thrust force? What is the basic formula? Thrust force is equal to VR bar dm by dt. I'm entering to the core idea of this entire variable mass concept. What is the direction of thrust force? Direction of thrust force should be determined using this formula. Okay, let's come for this. The fuel is being burned at a rate mu. Mu is what? the rate at which fuel is burnt. Will I agree this? And still I see that rocket is at rest. Now also it is at rest. Time being, let me take a condition like this. And now, sir, how to determine what direction the thrust force will act, what direction the friction. So let's begin like this. So mass of the fuel, mass of the system increasing or decreasing, no? So substitute that with negative sign. In what direction the gases are ejected? Towards left. And the mass of system decreasing. So then I'll put negative sign. Then how this equation, it will turn up like this. Minus of VR, dm by dt is how much? Okay, that's, I'll write it. Minus mu. So how much it will become? Minus mu VR bar. So what should be the direction of thrust force? Opposite to the VR U relative. So therefore, the thrust force should act in this direction. Are you getting the idea? I'm starting the discussion from here. In every numerical, this is what you have to search. In what direction the mass is being ejected. Get this? Mass of system increasing or decreasing? It is decreasing. Then the thrust force should act opposite to VR bar. VR bar will be given for us, or VR bar, what happened? We have to search in a problem. So definitely I know when I switch on the rocket in what direction the mass is ejected here. So because this is the front part, this is the back part. So from this, or I'll call this a nozzle. So from where the gas will be ejected, from the nozzles only. So in every system, what you should identify, from in which direction the mass is being ejected. So this is the ejected mass. This is the ejected mass. So I'll write it. This is the ejected mass. Then there's a direction of ejected mass. Mass of system decreasing. I'm writing minus mu. So what is the account of the relationship? Look at this negative sign. So how thrust force should be opposite to VR bar. Thrust force will act here. Now if I say that the rocket still at rest, means what direction the friction we have to show it? Towards left. Direction of friction. So will it be static or kinetic? Will be static, no? Will be static. So how much that should be equal to? Mu into VR. What is the basic equation? We'll write it. Magnitude I'm writing out. So finally, so the friction acting will be static in nature. Now, let it accelerate. Let this rocket accelerate. I'm slightly deviating away from the book. In books, what happened? Everything they have taken some mathematically trying to convince here. So let's have a general idea first. Then we'll enter into numerical. It'll be very easy for us to manage. So now the rocket. Now the thrust force generated in the system is such that it is able to overcome. So the thrust force is greater than the limiting. I'll adjust, sir, how do you can do like that? I can either adjust mu or VR, no? By controlling the size of the nozzles, I can control the mu, the rate at which fuel is burnt, and also VR. So using some mechanism, I can control mu and VR. Now I'll make mu and VR is such that the thrust force is able to overcome the limiting friction. In that case, the friction acting will be kinetic. The gases are ejected with a speed VR. Now again here also, mass of system increasing or decreasing? Mass of system m naught minus mu t. It is decreasing. Ejected gas. Got this, no? So in what direction the thrust force should act now? The thrust force must act in this direction. Then the relative acceleration, the acceleration of the rocket should be Ft. This is Ft minus Fk should be equal to ma. What is thrust force? mu into VR. Now don't already all the things I taken care directly. I'm coming to this one. Why towards right? Because of this condition. Because mass is decreasing, then thrust force should be opposite to VR. Minus what I should write, mu k, normal contact, and this is mg, no? So then it should be equal to 2 mu's are there. Mu k, I'll write it, no problem. Mu k n equal to me. Mu minus mu k mg equal to me. This should be equal to what is m? M will be m naught minus mu t, g equal to m naught minus mu t by e. Mu vr by m naught minus mu t minus mu k equal to a. So this expression for acceleration as a function. Differentiate dv by dt and solve it. You'll get the velocity of the rocket at any time t. So what is the most important part of this variable mass concept here? In what direction the mass is ejected, or in what direction the mass is received by the system? Means first, what is a system? Is it a rocket or a ground? Rocket is a system. Then in what direction mass is ejected? And in what is the VR? Then at what rate the fuel is burnt? Then afterwards, making a guess of the thrust force. How to get the thrust force? Ft is equal to thrust force equal to VR minus